historical here. So they are mutable. That means they can be changed, okay? And they are ordered. That means we can access each object in the list using indexing that starts from 0, all right? And they are heterogeneous. That means we can contain any data type. We have here an integer, we have here a string, we have a float, we have a list. So a list of lists. So this is a nested list inside another list, all right? And then it can contain duplicates. So we can have another string which has the same name. And that is as opposed to other data structures or data types. So those are the characteristics of a list. Yeah, so why do we need to use a list? First of all, they are easy to manipulate. It's very flexible because we can invoke different methods or functions. It also can contain duplicate elements just in case you're working on a data or you're working on a project that needs you to have like same elements, even though there's a way of going about that. Then you would probably want to use a list. And of course, it's heterogeneous, which means you can use any data type. And it's mutable, that means we can change the objects or the elements inside a list. So let's try to create a Python list. So how do we create a Python list? Let me, I hope you're seeing my screen. I'm trying to move to another screen. Okay, let me just, ideally I shouldn't, when I change, I should just, shouldn't interfere with me, but now I have to do this. So how do we create a list? So we create a list, there are several ways of creating a list. We can use a list constructor. Are you seeing what I'm typing? Okay. So you can use a list constructor. So first of all, let me just emphasize, when I mean that a list is a sequence of iterable objects that are mutable. So what do I mean by this? That are mutable. So number one, what needs to come to your mind, everything in Python, everything in Python is an object. Okay? And an object is an instance of a class. I'm not getting into object-oriented programming, but I want, for the sake of this explanation, an object is an instance of a class. And what do I mean by this? For instance, everything in Python is an object. So if A is equal to 5, so if I do type A, if I look at the type of A, then it shows me this is an integer, okay? So, and it's of the class int. It's an int, it's of the class integer, all right? Let me try something else like a function. So this shows it's of an int class int. What if I do something like this? This should show that I'm trying to justify why we are saying so that this is a float. Please let me know if somebody's raising their hand, because I'm not looking at there. I'm just focusing in here. So this is a float. Or if you want it bigger, I can increase it. So this is a float. It's of a type float. If we put this and this, so this will be a string. So of a type string. So this is an object. Let's start by maybe list one. So we can use what's called a constructor, this is a constructor of creating a list. So a constructor is a special, how do you call it? It's like a special method, or a special way of constructing a list. And we can also do this. We can also use this one and create a list. So all these are all valid. ways of creating lists, list one, and for instance, we can put something here. Why is it not creating? So we can create either this way, or you can create either this way by putting this one, this one, this one there. And you can create that list. Okay, I hope that makes sense. So we've created these two lists, list one and list two, and with this how we construct it. And another thing that also we need to learn about lists, like we said that it can contain, it is heterogeneous. So that means it can contain different characters, different data types. So for instance, it can also contain like a string, ages. So that's still, this is still valid, or it can contain even another list, a nested list inside that list. So this is still also valid. This is also valid. Yeah, let me remove this one. So this is also valid. So we have this a list inside a list, okay? And what is another characteristic? So we've said that it's mutable, it's heterogeneous. So this is the heterogeneous characteristic of a list, and it's mutable. That means we can manipulate it. We can, for instance, we can change maybe something in. Let me say list one. We can maybe change something in list. We can put something in list one. So we can say maybe in position 0, we want something in position 0 that's different. So maybe we want maybe to insert maybe 3, maybe that one. So if we print list 1, so we should now have it with the new, we've added something into this list. So that means this list, it is mutable. We can change it. And also we can have duplicates. So for instance, we want to add in position, let's add in position 4, the same number. So you can see we have this is the 0th position, 1, 2, 3, 4. So we can add duplicates, it can contain duplicates, and you can see it's in here. So mutability, like we said, we can change these objects inside the list. We can, okay, let's do manipulations. Let me see what we have here in the notes. So we can, the list can be created using either the list constructor or using the square brackets, like we've done. And we've done that using the square brackets, heterogeneous. Yeah, basically that and that and that. So manipulating a list. So we can, when we start manipulating a list, we maybe the first thing we can do, can check the length of the list. Benjamin, let me know if somebody wants to join or something, because I'm not looking at, or if somebody has raised their hands, let me know. So the length function is an inbuilt function or a method that acts on this list called list1. So what we are actually doing, we are just ascertaining that this list has 7 elements in it. We can check that this is 1, 2, 3, 4, 5, 6, 7, because this is another element, even though it's a list in there. Somebody wants to join? Oh, okay. All right. Yes. So that's one thing. So we can get the element of a list. We can also do what's called pop. We can now start using the invoke functions. So basically what we're doing, like we can pop out maybe some of these elements in this list, like we can remove them. And how do we do that? We use the pop function. So what we just do, we use what's called object dot syntax dot object notation. A syntax called syntax dot object notation. And like I've told you, everything in Python is an object. Okay. So what does this mean? This means like this. The name of our list is list1 for now. So list1, and let's pop something. So pop is an inbuilt method in Python. Okay. And I want to pop out, I think normally this pops out the last element. So let's see, I want to pop out. So what's basically what this method is doing, it's invoked on this object called list1. Like remember, always, everything in Python is an object. And we want to invoke this method on this list called list1. And this dot just means invoking, okay? And this is a method, you can call it a function. Either way, it's okay. We can interchangeably use the terminology. So when we do this, when now we print list1, or let's pop, I think pop normally pop, if you pop invalid list1 dot pop. So like I've said, we pop out this last element from list1. And now let's check list1. What is it now? So when we check now, what does it contain? You can see now it doesn't have this particular. This element has been removed. Okay. And you can also do that for, I believe, for a particular element. So for instance, dot pop, this one dot pop, I think is element of 0 index, as an integer. Pop is an integer. I have it somewhere in my notes. So let's see. This one dot pop. Yeah, it's working. So we have popped out the element in the 0th position, which is this one. Okay, and you can see it in here. Okay, we can also append. We can also append something on this list. Append just means adding. So we still have that list1, the list1 dot append. And append just means, oh, we have to append something here. I think let's append maybe 23. Let's see. Append, I think we need do we need to list and then now let's check list1. Let me put something that's a bit conspicuous. And now if we check list1, so you can see it's added my name in there in this list. Yeah, and we can also do list1 remove or insert list1. I think so. Dot remove. So we can remove an object from list1. So remove, I think we can remove maybe, let's remove it. And if now we print list1, if we print list1 here, you find now that it doesn't have this name Peter in there. We have removed it already. Okay, and we have so many methods. Let's see, we can also do list1 dot clear. I think so. This should clear everything in that list, I believe. So if we do list1, it should if we print list1 now, we get an empty list. And we can also delete, we can also add, let's now probably maybe do list2, L2. So this is L2 and this L2 has this, or has these elements. 1, and we want to add, we can add, let's assign, we can assign another element using now the indexing style. So let's say, for instance, we can just say L2. At L2, we want to, at L2, at the first position, we want to add something. I think we have not done this. So we want at the first position, at the first index position, we want to assign something different from what was there before. So let's say we want to assign this maybe a float of 3.4 to that particular position. All right, and we just print that L2. Now you see we've already assigned it. We don't have one now. We've assigned 3.4 to that particular position. And of course, we can also assign a list to this particular position. So for instance, we can add a list in here. Let me put something more like maybe 22.3, maybe 54, maybe, yeah, something like that. So you can see we've added into the first position this one. Now we have this list or list in here. Now another very interesting, or we can also use another one. I think it's called extend. There are many. I'm just refreshing my brain, and these are things that I'll give you the note, and you can also when you read, you'll find a lot of the list, how you to manipulate the list. I don't know whether we've done insert. I think insert we need 2 arguments. So maybe in the first position we want to insert George, something like that. So I've inserted. So let me check if it's there. Yeah, you see that works the way we want it. Yeah, and remember this listed one is in the first position, which is 0. So that's why showing this and then this. So this is the first position. So yes, as you can see, it's the first position. And what else? Oh, it's running everything. Anyway, the length is 5. So basically what I'm doing, I want to iterate over every element in 5. That means 1, blah, 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 something like that. So print each item using index number. So I'm using the index number to print each item in each position. So basically that's why we are getting this. If we run this, we get all this that's coming out here. Okay. Another thing that we can do with yeah, so let's try and do indexing. So what is indexing? Indexing is just a way of slicing. I mean, we've done indexing. So slicing is just a way of, for instance, capturing elements within this list in a particular range. For instance, I want to slice my list and with a chunk of, I want to skip by, I want to slice the ones in positions which are even. So we can do this, and that one should be able to. I think I need. Let me see first. My list. All right, let me go slow first of all. Let me not jump to that fast. Okay, so if we want to grab everything in the entire list, this is how we grab it. This will grab everything in that entire list. We'll just return to you. Why is it misbehaving? Okay, sometimes this messes up a little bit. Let me just do another one, maybe L3. So L3 is here. So I want to grab everything in L3. So what I'll just do, I'll do this. If you put this, maybe, so what you are grabbing all the data in this list. So that's 1, 2, 3, 4, 5. So when we do that, we are grabbing that, and this picks up for us everything. We can grab only from the starting point to the second element. So we can do like this. So we are slicing. So you can see here from the first, which is 0, 1, 2, 3. So that's what exactly we get. We are not having this. We are just truncating this 1, 2, 3, only that. We can also start from 2 going onward. So for instance, we can slice hive off from 2. We don't want 1. That means you don't want what's in position 1. So you just want the data from 3 for and position 1, of course, is 2. So we are excluding 0th position data and the first data. So we just want 3, 4, 5. Okay. And we can also limit further. Let's say, for instance, to 4. Let's say what would we grab? So we are only slicing from position 2, which is 0, 1, 2. Okay. So we start from 3 and 4, excluding 5. So 0, 0, 1, 2, 2 starts from here, going up to the 4th. So 1, 2, 3, 4. So we grab that and we exclude the other ones. We can also do what's called, what is it called? This negative indexing. But before that, let me try to do what I wanted to do. I think we can also reverse this string. I think we did that before with you guys earlier on, somewhere. We did something like this. Yeah, so this reverses the string for us. So instead of starting from 1, 2, 3, 4, we start from 4, blah, blah. So this reverses for us. And we can also do this. Yeah. So this is skipping. We are skipping. We are like jumping. So we are printing 1. We are skipping 2. We are then again 3. Then skip 4. That way. Okay. And there's also what's called negative indexing. So negative indexing is just indexing but from the other direction. Okay. So this now gives we are chopping off only 5. When we do it like this, we are chopping off only 5. And of course, the other way we've done that, if you do this, you are starting from the other way. There's a whole lot of this that needs to be done, but yeah, -1. So this gives us the entire list from the other from the opposite direction. All these are very, very instrumental for you. You will need them. So let me check what else we need to do with lists. Adding elements to the list. We've done append, display position in the list. Yeah, there's also we can also insert. I was trying to do the insert. I don't know whether we succeeded. L3 dot insert something. So we want to start. I think we did this law in the 3rd position. Maybe let's insert a string. So let's say maybe sit. I'm not quite sure if we did. I think we must have done it. So if we print this L3, the 3rd list, it should have now sit in it. I think we did that. What else did we need to do? We can also extend. I think I tried it and it didn't work. Let's say we want to extend this again. So we can do it this way. So L3 dot extend, and then we have that. So maybe extend with this list. And then we have that, and then you close it. And then let's see what is L3 now. Closing parenthesis. Where is the mistake? Are you seeing any mistake anywhere? Yeah, it should be. Yeah, I'm making a mistake. here. Yeah, so you can see we've extended with this one. I think maybe for visibility's sake, maybe you can put something like extended. I hope this makes sense to us. Yeah, we can see that it's added here nicely for us. So we can use also that function, extended inbuilt function. So modifying a list, we've done some about modifying a list. So I'm modifying all items. Yeah, we've done that. I think we've squared in that. Let me see. Where? So I was trying to do this. So let's say for let me check again. For I in range my list. So it's for I in range L3. Yeah, I think so. So I wanted to square every element in the list. So I'll just I'll do L3, and then I'll pick the ith element, and then I multiply it by itself. I element I multiply it by I again, and then I just want I'm just making sure that I is the square. So this line of code, so this will be L3, then I is equal to square. And I think we print let's print square, should be square, out of the for loop. Hope it works already. We want it to work. List object cannot be interpreted as an integer. So where am I making a mistake? I think what if I print L3 I? Let me just check how I did it here. My list. Oh, I'm supposed to print the list. Where am I making a mistake? This. For I in range L3, square L3I times L3I. L3I is equal to yeah, what's the issue? Square my list is equal to square. It's basically how I did it in my list. Yeah, we have not grabbed the range, so it might not work that way. So this way should work now. Okay. So for I in range, because like I've explained, this just gives us L3, gives us the reason why gives us something to work with. So yeah, like this. So we are iterating over this. When we get the length here, which is 1, 2, 3, 4, 5, then now we iterate over those. And now we are multiplying 1 times 1, 2 times 2, 3 times 3, 4 times 4, blah, blah, that way. And then we are getting this. So basically, that's what I wanted to do the other time. Yeah. What other manipulation can we? There are so many other manipulations. We can also remove something. We can L3. Then I don't think we've done this. L3 dot remove. So you can remove maybe 1. So for instance, and if we print L3, you can see that we've removed 1 from the list. Okay. And what else? We've removed that, remove all occurrences. So for instance, we can also remove if a list has, like for instance, this list over here. This list here, we can just also remove my list dot remove. So this will remove us the duplicates. So if we remove all occurrences of 6, I think so. Okay. So if we just print my list, we find that what has it done? It's printed exactly what happened. First of all, let me print my lists. 4666. So I want to remove. So I need this my list dot remove the number that I want to remove. And now if I print my list, so I've removed 6. So we don't have the duplicates now. If we print it now, we only have this 1, 6. Okay. Are we together? Any question up there? Are we together? Okay. Yeah. Okay, you guys are good so far. All right. So let me check if there's anything that we need to remove. Item present at a given list. We've done pop, remove the range of items. So there's also a very interesting one. We can remove the items within a particular. So like for instance, where is it? So this is my list. Dot remove. Dot remove. I think from index, the second index. Yeah. Remove my list dot remove invalid syntax. My list dot remove from. Is that really correct? Yeah, it should be like my list. So first of all, let's ascertain my list. That's my list. And then we can use the del keyword on my list. So we remove from position 2 to maybe 3. And let's see my list if it's removed. So we can see we have only now, we've removed from 4, 6, 8, 12. Or is it second? 0, 1, 2, 3. So we've removed 8. I think 8 and 12. We remove second. We've only removed one element because it's just for position 2 to position 3, which is 8. Yeah, we remove 8. We can start even from 0 to the sorry, 0 to the so 0. So we are going this way from the start to the third one. So that should be 0, 1, 2, 3. What are we getting? Let me add a few here. My my list. Let me just do one alone. Is equal to so we want to delete del L5 from let's say from the third one, from the fourth one going onwards. So L5 here now will be 1, 2, 3, 4, 5. So we remove the fourth one. Only the fourth one. Let's say yeah. So we have only one because we've removed from 0, 1. So 1, 2, 3, 4, 5, 6. So we've started removing from here, and we are remaining with one only, which is here. So you will find these manipulations very, very important for you when you're working with Python a lot. Let me see if there's anything that I need to cover. You can also concatenate two lists, and that is very simple. That is how do we go about it? Dot extend. I think it's something. Let's see. We have L5, so we can add L6 is equal to L6. Maybe L6 is equal to 7, 8, 9, 10. So let's extend list L5 up to 10. So and one list. So we can do L5 dot extend L6 dot L5 dot extend L6. So let me see L5 if we have extended it. Yeah, so we have extended it. So now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So previously it was just up to 6. Now we've added 7, 8, 9, 10 to the end. So it adds to the end of it. Another manipulation, let's see. Alternatively, you can just add them this way. Alternatively, you can just do L5 plus L6, and that would still be valid. All right. What else can we do with this list? This also you can copy. We can say L5. Let's say L5 is equal to L6. So L7 is equal to and then L7 is not that this. Let me check first of all. Copying our list. Let's call it deep copying. Like we can say L5 is equal to, at this I don't even think we will use this a lot. So L5, L7 would be L7 is equal to L5, and then we print L7. So let me see, L7 is equal to L5. So L7, 7, 8, 9, 10. And L5 initially was just this one. So we have, let me see, L7, 7, 8, 9, 10. Did we do the right thing? 7, 8, 9, 10. It's copying something different. L7, it's L5 or L6. 7, 8, 9, 10. I don't know what it's doing, but basically it's called deep copying. It's like just pasting into you are emptying another container and then you're copying it to the other one. So that one is a very simple one, so I don't even need to go into that. List operations, we've done quite a number of list operations. We can also sort a list. Reversing, we've done reverse using indexing. You can use the indexing, or we can do something like let's try and sort this L9. L9 is equal to maybe 23, 3, 5, 6, 7, 8, 4, 2, something like that. Okay, and then L9 dot sort, and then L9. So this basically means it sorts out them in ascending order, as you can see, depending in the order of, I mean, what is it in incremental order, because this is minimum that way. Yeah. Another one, let me check. Building function list. We now have those ones like you can sum up a list. You can avoid those long. You can just maybe sum and then use L9, and you get it's this way. I tried to do something like this. I don't know whether you can remember. Total. It's a long one, but it's normally good to know it. So whatever we put in here, and then I think I did this. I initialized total to 0. I think I did for I in for I. Total is equal to 0. What did I do for I in? Let me use. It could be a keyword. What did I do? Is it for I in total? For I in total, what is it? So no, for I in L9, because we are talking about, let me use something that's not confusing me. Nums, for I in nums, total plus I, and then I think we return total. Is it? We return total. I'm just taking a long way, but it's good to know it also this way, even though it's longer. The other one is just good for you to do very short. You just want to do very short. You just want to sum up things very quickly. But if you want to use this later on in the program, if it's a big program, you'd rather do it there this way that I'm showing you. So we need to pass in something in here, which is this one. Okay. Yeah. So if we pass in this, I think so we get the same 170 as what did we get? Was it that one? We get 117. Let me, if we total these nums, so sum nums, we should just get the same, I believe. It's the same, so it's working. This function is working the way we want it, because we're getting the same. We're getting the same number here, and we're getting the same number. So this is the shorter one. This is the longer one, but I like doing it this way so that you know how you can use it later on in a program that's long. By returning this, you can pick up this return value and then use it somewhere else. All right, so yeah, it's mine. time utilized very well. Another thing, let me see. It's use list is not very complicated. I'll do this what's called list comprehension, which I normally like a lot. Yeah, I think I'll do a list comprehension next time. Any question? I think this is an easy one for you guys. So is it easy? Anybody with a question? Everybody understood? Everything understood? All right. I think we are all good in that. We didn't have a break because I don't think this was very intense. So we still have like 12 minutes thereabout. Yeah, so I'm done with that presentation. So what I wanted us to, I'm done with that class. So pending, I want us to talk about the pending things for us.